So thanks for the brief introduction. I'm Dave Berenstein. I'm doing ML and DevRel at Argilla. And for the ones that don't know Argilla is a data collaboration platform that focuses on two main user personas: the domain experts that really know what they're talking about in terms of the NLP models that you would like to train, and the other ones, the AI engineers. And the AI engineers normally prepare the data sets in such a way that the domain experts can really provide as efficient feedback as possible. So think about adding vectors, adding metadata, filters, adding initial model suggestions and predictions from like predictive models, but also from LLMs nowadays, so more the generative approach. And today I'm going to talk to you about what a GPU poor company or individual can do in order to actually start fine-tuning your own LLMs and go from GPU poor to data rich, and the data quality practices that we've been preaching at Argilla the last year. So as a smaller individual company, you can actually train your own LLM, and then you can actually do that by, due to the fact that there's more and more consumer GPUs that you can use for fine-tuning methods like Colab and RunPod. For example, the first pre-training phase is normally quite expensive for LLMs, and then you'll end up spending like 1 million euros, but you can actually skip that pre-training phase and then continue with pre-trained OSS model that's already been published and publicized by companies like Meta and these kind of companies. So there's also more and more of these models publicly available, both for large language models like the 5 models, but also the larger language models going from maybe 7 to 70 billion. On top of that, there's also more and more open source training code available, and normally also all of these training codes get added based on the new research that's being published. For example, the ORPO fine-tuning method that was introduced a while back actually got added to the TRL library from Hugging Face a couple weeks after the release. So that's really cool to see that the open source community and the researchers are contributing to these kind of things quite quickly and iterating to kind of compete with the closed source and closed source companies. And on top of that, there's also the rise of synthetic data. And synthetic data sounds a bit weird because you actually use LLMs to generate data for fine-tuning LLMs, but it's actually something that's works, and that's actually proven to work for several LLMs, and some of the use cases that I'll go over actually go into these kind of things as well. And a cool example is also the Open Hermes preference dataset that we actually created together with Hugging Face and our research team, where we created this 1 million data point synthetic dataset for fine-tuning LLMs as well. And we did that by using the Open Hermes model that's like a publicly available LLM. So we've got all the tools. We've got some consumer compute we can get from RunPod, from Colab, and these kind of things. And we've got like the training code, the models, and even synthetic data to really speed up the process from going from ideation to actually fine-tuning a model and having a proper data set. But we actually need high quality data. So we actually need to improve our data set. And in order to kind of understand what the data is about, I want to kind of go over the 3 training steps for LLM fine-tuning, which are like the pre-training phase. And the pre-training phase is a phase that really focuses on masked language modeling and learning a model, forcing a model to learn how language works. And how language works can be done by forwarding a lot of these data to raw text sources and really focusing on quantity data over quality data. And for this step, normally you require a lot of industry compute in order to get it done. And this is also why it's very difficult to do this phase yourself as an individual company or small company, because it's quite expensive to do that. And this really relies on the masked language modeling approach that we've also seen for the previous generations of transformers, where you kind of enforce a model to learn to fill in masks and learn how languages work and semantic meanings of words in sentences occur. Then the next phase, you actually take this pre-trained model, which is like very expensive, and then you do instruction fine-tuning, which once again relies on masked language modeling. but then you enforce the model to replicate the output behavior based on a chat template. And this chat template is something you can see like the system message, user message, and the assistant message, where you have like a one-turn interaction in the center, on the side, and multi-turn interaction. And this is normally done with structured data sources that really rely on higher quality data, instead of huge quantities as in the first phase. And these kind of phases, due to the new fine-tuning techniques that that I mentioned before, can actually be done on consumer compute as well. And then you take that model that you get from the SFT phase, and you actually go to the alignment phase, or the RLHF human alignment process. And there you want to align the model that you had from the SFT with human preferences. So really have to add some nuance and some like specific domain nuance that you want within your model. And you do that by having your initial prompt, you can see in the center, and then choosing a chosen pair as a generation completion and a rejected response as a generation completion. And also this step focuses on quality over quantity. And once again, these steps can also be done on consumer compute. So initially, this was done with RLHF, which everyone probably knows from OpenAI. This is how they trained their first ChatGPT models. But this normally relied on training first a reward model, then a policy model, then a reward model, policy model. So this is quite a complex process, because you train two separate models, so you need to iterate every time and look at the data, and takes a lot of compute and a lot of human involvement. But nowadays, most of the models are actually trained with this DPO fine-tuning algorithm. And this DPO fine-tuning algorithm optimizes a single loss function for these things combined. So it really simplifies the process. But yeah, loss functions are a bit complex, and I just came back from holidays, so I didn't want to spend too much time on that. So instead, you can actually focus on this. So you have your initial prompt, and you have two responses, and one response is better than the other. And for the LLM training phases where you really focus on data quality, are the second and the third phase. And that's also achievable on consumer compute. So that's really why we and I will also focus this talk on the last two phases. And we have a cool blog series on alignment methods, where we kind of go into all of these different techniques, so PPO, DPO, all of the shebang. And if you want, you can kind of go to the website. It's a collaborative blog series together with Notus NLP, like a NLP consultancy based in Europe. So we need data quality, and then what? And we actually have 4 use cases that we've seen this for: Stanford Alpaca, Databricks Dolly, OpenBNB, UltraFeedback, and eventually also a collaborative approach we launched together with Hugging Face to create our own data set. So the first 3 are about dataset cleaning and assessing some errors that they made within their data. And the last one is about a data set that we created together with Hugging Face and our community. So Stanford Alpaca was a data set that was introduced by Stanford Research with 52K SFT examples, so the second phase for the fine-tuning. And this was done with synthetic data. So they were actually using self-instruct, which is a prompt template. So you prompt an LLM together with a template to rewrite, for example, an instruction or a prompt response pair to a better or similar prompt response pair. And this was done using text affinity tree. This is like one of the earlier models from OpenAI that got a lot of hype. And it's also one of the models that was actually a bit toxic and not as good as the models we see nowadays. And this was done based on fine-grained categories like brainstorming or summarization or these kind of things. So they actually took the pre-trained meta model, then applied SFT to it, and then ended up with Alpaca 7B. The problem was that this data set actually contained a lot of references to non-existent content. So for example, you would get a reference to an API method, as you can see here, in the instruction, even though the model doesn't really have access to any API methods. And then the output would be like some gibberish hallucination about an API that doesn't exist for the knowledge model of the model. And there were also a lot more things like toxicity and other things that arose within that model. So the solution can be quite simple. What we did was train a set fit classifier. For the people that don't know set fit, it's a few shots classification method for text classification. And normally you only need like roughly 8 samples per label in order to train a decent model, and it's quite quick to iterate. And we applied 2 labels, clean and dirty, and then we trained the Alpaca garbage collector for multilingual classification for these kind of dirty records or dirty data entries. And you can actually make predictions on all of your data. And then if you go to Argilla or any other nice UI for data cleaning, you can actually kind of filter, for example, on the label that you've applied and kind of skim through all of your dirty records a lot easier than you would do like by hand and looking into them by hand. And another cool thing that was recently released is FastFit. It's kind of a competitor or something built upon SetFit, and I really like the title for the research paper. So if you don't want to do few-shot classification with LLMs, you can actually use FastFit. It normally trains a lot faster than SetFit, but the inference is a bit slower. So easy to iterate, but if you really want to scale, might not be the best approach. The next one is Databricks Dolly, the dataset where the Databricks employees were asked by Databricks to actually create this 15K high-quality SFT dataset, once again for the second phase. And this dataset, 5K employees are all asked to kind of create a prompt and response. So this is once again with the fine-grained categories for example, brainstorming or summarization. And what you can see here is one example of what that might look like. So what the problem was here was that there might have been wrong annotation guidelines, or the employees were not motivated for some reason, because the length for summarization was often longer than the length for the actual input context that they had to summarize. There were a lot of like context copy-pasting from exactly from Wikipedia, and there were also a lot of references and URLs. So once again, the missing content. So if you were to train a model on data with a lot of these URL brackets, then eventually these URL brackets also come up when the model needs to start generating data, and that's not like the best approach. So as you can see here, this is one of the prime examples for Dolly 2.0 on their website, and as you can see, there's actually a fake URL to a Twitter account that's been generated by Dolly. So what we did was use this text descriptives package, which is an NLP package, apply some basic heuristics and apply some basic assessments on how complicated or what the quality of the text is. And based on that, you can actually kind of filter out like a lot of these length summarization, length input issues, or a lot of these references that you might miss or don't want to have in your text. And based on this, we were actually able to quite easily change 20% of all of the data within the so-called Dolly dataset. And it was quite a nice result. And on top of that, we actually provided some default translations for each one of these entries, so that people could actually use it for other languages as well, like for Germany, for German, English, Spanish, and French as an output. For Databricks Dolly, I can also recommend looking at the text tip package, and they have a cool tutorial to actually filtering corpora, text corpora based on text quality. So there's like these heuristics for the quality assessment for text, and they can kind of grade text on high school level or middle school level or uni level. And yeah, based on that, you can actually already filter out a lot of garbage by having like human involvement, but still doing it in a smart way. Then there's the open B&B UltraFeedback dataset that was synthetically generated with 64K prompts, but the open B&B UltraFeedback dataset synthetically generated 64K prompts with an instruction pool of prompts from different datasets like UltraChat, GPT, well-known datasets within the LLM fine-tuning space, and then a model pool that was used to create completions for this data. So actually, these completions and prompts were then rated by GPT-4, so using LLMs as judges for quality of annotations and completions based on these instruction following criteria, truthfulness criteria, and also one single overall rating for the prompt and response. But what we actually found when looking at the data was that you would get these gibberish records where you have the prompt, which one is an animal, book, or pen, and the chosen response would then be pen is an animal, book is an animal, and pen is an animal, which is complete gibberish, but it would end up getting a 10 score from apparently the GPT-4 rating. So when looking into the code from OpenBNB and the research behind that, we saw that there was a coding error, leading all of the ones being transformed to a 10, and then you actually trained your model on completely opposite kind of pairs for fine-tuning. So on top of that, there were some incomplete ratings, so not all models responded, and some ties in the data. So then there would be like a preference pair, but then the actual scores would be the same. So it also doesn't really make sense. So what we did was actually use, instead of these overall ratings that Hugging Face and the OpenBNB team used for fine-tuning the Zephyr model, we actually used to have these averaged out ratings for each one of these individual criteria that I just mentioned, like the truthfulness, helpfulness, and these kind of things, and then use that as a rating because they didn't contain a coding error. And what we actually saw was also that these overall rating scores were actually quite well aligned with the averaged out individual rating scores. So there was a lot of correlation. So in terms of costs, whenever you want to do judging, it's probably best to do an overall score to avoid some of the cost. And what we did was train a model. Notus 7B was well received by the community and also the research team of Hugging Face that initially trained the Zephyr model. And the Zephyr model was trained on the dirty UltraFeedback dataset, and then the 7B model on the clean version. And that's actually also a snippet of how you can use the model. So for the ones that don't know LLM, it's quite a cool package that you can install relatively easily with 3 command lines arguments. You can actually have your own LLM up and running locally. And then the one with Hugging Face, so this one is about synthetic data and human data, a mix of 52K prompts that we sourced from different data sets that were publicized publicly. And the problem that we tried to cover was that there's not much human evaluation in LLM data, and we want to see if humans actually preferred human or synthetic data. So the solution that we came up with was actually hosting Argilla Hugging Face space, Argilla instance on Hugging Face spaces, and asking the community to rate all of these responses based on the quality that, all of these prompts based on the quality of the prompt. So here we really focus on the quality of the prompt instead of the response. And then afterwards, we decided to use Mistral Large, so yeah, at the time, the state-of-the-art model, to create synthetically generated responses for each one of these initial prompts. And then we actually trained the applied spin as a fine-tuning technique, the first reproduction of our research paper, and we actually shared this on GitHub and publicly published a model. So if you want to reproduce and play around with spin, you can actually go to this GitHub repo. It can be found online as well, and then also do that yourself. So what we've been saying is that data quality and human feedback are important for us at Argilla and also for the entire NLP space. But that's not just us, but also some research papers. So for example, the LIMA paper that was published half a year ago actually used only 1K examples for doing SFT. And these were like highly curated, manually curated, high quality and diverse examples that were created by the research team behind this paper. It was lacking in math and coding because it can be difficult to actually come up with useful and sensible math and coding questions. And then there's also the data paper, which really focused on finding good data for alignment of models. And this data paper actually combined a more complex pipeline with prompt templating and using LLMs to rewrite in prompts for LLMs. So you would once again forward that prompt to a high quality LLM, rewrite that prompt into a more diverse or more higher quality example, and then use that same LLM to rate the score, and do the same for the responses. So you would kind of evolve the quality, the complexity of the prompt, and then evolve the quality of the response as well. And then do some diversity data filtering based on the scores that the LLM used as a judge. So you would kind of spread out based on spread out all of your records based on embeddings, and then pick the most representative exemplars for each one of these based on the scores that they got from LLMs. So a more complex pipeline, still a lot of model involvement, but also a lot of human involvement. And the same holds for the AI open foundation models, where they actually set up this pre-trained pre-training filters for their pre-training data set. And this is like a very complex pipeline that goes from data collection of raw web data, language filtering, perplexity filtering, a lot of these more intuitive heuristics that you can actually apply. And for me, this is also a good example of, once again, human involvement, but also with some smart shortcuts to actually make it work a bit better. And once again, they also use this evil complexity prompt template to kind of improve the prompts using LLMs. So I would say that data quality and human feedback are important. And some pointers to get you started. So quality is better than quantity data, I would say, but how much is enough quantity? For SFT, so the second phase of the fine-tuning, what we've seen work is like roughly 6,000 to 10,000 examples, high quality examples for curated data, where we would kind of reduce the dataset size to this amount, and then we would get often a better model that you didn't need to train as long because you have less data, and with better benchmarking results. And the same holds for DPO. But then for DPO, we've seen results even work for 3,000 examples in practice. And for the bare necessities are really getting your hands dirty, looking at the records, and having good annotation guidelines, because otherwise nobody knows what they're actually talking about and how things work. And that's also a thing that we've seen with the Data is Better Together initiative, that we weren't entirely sure what problems might arise when people actually were evaluating records. And it's good to start simple. So you can, for example, add embeddings so that you can do similarity search to find similar records, and apply this classification, for example, with setfit to find some initial assumptions based on some classification that you might do. Do something like text descriptive, topic modeling, and then end complex whenever you actually know what's in your data and what you're talking about, and maybe use LLMs as prompt engineers, so the evil quality and complexity thing that you've seen in the data paper and the AI paper. And then after, you can also use LLMs as judges, but then you can better use an overall rating to do that. And this is a cool generated song about data quality. We'll share it later. Some more cool things. So we've got this cool pipelining framework for synthetic data generation, which is called distilabel. You can actually create reproducible complex pipelines like the data paper or like the AI paper. There's this KTO preference handbook. So KTO is a different fine-tuning approach that relies on just +1, -1, so to say, binary signals instead of comparison data. So that makes it a bit more easier. And not that well researched in practice, so it might be interesting to have a look at that. And there's a multilingual prompt evaluation project that we've launched, and there's still no Italian person that is a language lead. So if anyone wants to get involved, feel free to reach out to me or join the Hugging Face or Argilla Discord. And then there's time for questions, feedback, and these kind of things.
Thank you. So thank you very much. That was very interesting. We have a couple of questions online. So the first one is, you mentioned that URLs can mess up the instruction tuning. Mm-hmm. What if you are tuning a model that will be used for RAG? Can it be tuned to use URL from context?
In terms of RAG, you would want the model not to start generating the URLs outside of the context window, so to say. So yes, it's possible, but then you really have to know that these URLs are like the same in your prompt and the response. And that's, once again, something that you would expect to see in your data. So, for example, the Dolly example that I gave, you would end up with a prompt without any URL, and then you get an URL as output, which is like a fake URL, quite likely. And then for this example, you would have your prompt, then you would have your context window that you provide as a thing for retrieval augmented generation, and then you would eventually get your response where you would expect the URL from the initial input to be the same as the output.
Thank you. And then we have another one. What sources should I check to stay up to date with the latest and best open source LLM models, compared to reading all the models' readmes and Hugging Face?
Yeah, Hugging Face is, I was going to say Hugging Face Paperspace is nice. LinkedIn, follow the right influencers, I would say. And yeah, things like Hacker News, social, a lot of these social media websites are nice to follow. And you can also follow us. We try to share everything about LLMs and about cool new models coming out.
Thanks. Any question from the room? Anyone? I have a question maybe for you.
Okay, cool.
So you said that you can use LLM as a judge. Did you do any research, or do you know any research on if the LLM can actually match the ratings of a human?
Yeah, I don't know the exact papers, but there has been some research that they align with human judgment. But normally these are just the larger LLMs. So GPT-4, Mistral Large, like the LLMs, you also tend to pay for a bit more. And if you want to kind of explore, so to say, how well they align with human judgment, I can recommend just labeling 100 records with a LLM as a judge, and then labeling 100 records with by humans, and then see what the correlation is or any other things that you might want to have a look at.
Thanks. We also have a question. Yeah, that is good. So why is it so common for model to gaslight on URLs?
To gaslight on URLs?
Yeah.
Can you rephrase gaslighting?
I'm not sure if the person is in the room can explain. I think like makes mistake on URL or try to predict
I think
fake URLs.
Because it's generally trained on a lot of like public data. So data from Reddit, from Wikipedia and these kind of things, and they normally tend to contain URLs. So that is one of the reasons that could be the case.
We have time for one question if anyone has any burning one. Or otherwise, will you be around for question hours?
I will be around. If someone wants stickers from Argilla, distilabel or anything, feel free to reach out, or want to chat about LLMs or NLP, feel free to reach out as well.
I want one sticker. So,
or live.
Thank you very much then.